The vacuum distillation unit continues the processing of the residue from the crude oil distillation unit. This residue is known as atmospheric residue, since it comes from the second tar of the crude oil distillation unit, which operates at atmospheric pressure. We are heating a sample of this residue, but it is chemically decomposing or cracking instead of boiling and cannot be distilled. This experiment, in which a pressure cooker is connected to a vacuum pump, shows the way in which we overcome the difficulty. Heated in air, water boils at 212 degrees Fahrenheit. The pressure of the air is 30 inches of mercury. But when we lower the pressure in the cooker with a vacuum pump, the boiling point of the water inside the cooker also falls, so that it boils at 140 degrees Fahrenheit. The pressure is now 5 inches of mercury. So, reducing the pressure of a liquid reduces the boiling point. This enables us to boil atmospheric residue. Heating at atmospheric pressure results in cracking and not boiling. By reducing the pressure, the boiling point is lowered to below the cracking temperature, making it possible to distill the residue. In the vacuum distillation unit, the pressure in the tar is reduced by a form of pump known as an ejector. On the plant, by blowing steam through the large pipe of the ejector, the vapors are drawn out of the tar, thus reducing the pressure in the plant. The vapors and steam from the tar are blown down the big pipe to a condenser and more ejectors further down the tar, because in practice, a sufficiently high vacuum cannot be obtained with one ejector. There are 3 ejectors at the top of the tar and 2 more sets of 3 about halfway down. They are arranged in 3 parallel series. This vacuum distillation unit serves the lubricating oil refinery, and it is required to produce a series of cuts. In the refinery, regular samples are taken to check the quality of the products. Here we can compare the incoming atmospheric residue with the products of the vacuum unit. These are the lightest, a vacuum gas oil, as an overhead product, and 4 waxy distillate side cuts. Number 1, number 2, number 3, number 4, and a heavy thick vacuum residue. Building up a flow diagram, we start with the feed, in this case, atmospheric residue. After initial heating in the heat exchangers, the flow is split so that the incoming residue passes through a fired heater. Even under reduced pressure, the atmospheric residue requires a great deal of heating before it boils. The partly vaporized oil is carried from the heater into the tar in several large diameter pipes. It enters above the 7th tray. This particular tar has 25 trays, the top tray being about 3/4 of the way up the tar. Above the top tray is one section deeply packed with earthenware rings. The rings are about 4 inches in diameter and loosely packed. This part of the tar is called the packed section. It serves the same purpose as several ordinary trays, and at the same time acts as a spray trap. As the atmospheric residue enters the tar, the vapors rise up, whilst the unvaporized part falls to the lower and narrower part of the tar, which is called the stripper section. The vacuum residue is stripped by superheated steam blown into the bottom of the tar. Vapor and steam are carried up. The stripped vacuum residue is pumped away through the heat exchangers, where it heats up the incoming atmospheric residue and is further cooled in a large cooler tank. Inside the cooler tank, the hot oil is in several parallel pipes which are surrounded by cooling water. As the vapors rise up the tower, they become cooler and lighter, and the liquid running down the tower darker and heavier. At any intermediate tray, the liquid will have a definite composition and can be drawn off as a side cut. At the level of the packed section, the rising vapors meet a reflux of gas oil flowing down over the earthenware rings. The cool oil flowing down the tower forms a thin film over each of the rings and so offers a large surface to the rising vapors, which become trapped and are absorbed in the oil. Vacuum gas oil is drawn off immediately below this packed section and removed from the tower. Steam introduced into the tower and strippers, together with any traces of oil vapors not condensed in the packed section, are removed from the tower by the first stage ejectors. Part are condensed and fall into the hot well. What remains uncondensed is then drawn into the second stage ejectors and condensers, from where the condensed liquid drains to the hot well. The third stage ejectors complete the process, and any last remaining gases are discharged to the atmosphere. The vacuum gas oil is withdrawn from a tray below the packed section and passed to a receiver. From here it is pumped back through coolers and the stream is split, part being returned as reflux to above the packed section of the tower. The remainder goes away to storage. The 4 side cuts are withdrawn from suitable trays. Number 1 cut is withdrawn, passed through a stripper, a heat exchanger, through a water cooler, and pumped to storage. The remaining cuts are withdrawn at various levels, stripped and cooled in the same way. By varying the number of the tray from which each side cut is withdrawn, a control is obtained over the quality of the cut. The last side cut passes through its heat exchanger into the products cooler and away to storage. To prevent the steam used in the strippers from cooling the oil, it is superheated beforehand in a separate fired heater. So, put simply, the way in which the vacuum distillation unit works is this. The steam ejectors lower the pressure in the tower to a vacuum of about 28 inches of mercury, or, put the other way round, an absolute pressure of 2 inches of mercury. This, in turn, lowers the boiling point of the atmospheric residue so that in the heater it needs only to be heated to a temperature of about 710 degrees Fahrenheit. It is only above about 800 degrees Fahrenheit that cracking or decomposition begins. The remainder of the process is the familiar one of taking off a full range of side cuts, stripping them with steam in a tall stripper tower, and cooling them in heat exchangers and cooler boxes. This unit serves a lubricating oil refinery. If it were required to provide only cracking stock, there would be fewer side cuts and the strippers might be omitted. To follow the flow through the plant, it is necessary to pick up the atmospheric residue at the point where it leaves the crude oil distillation unit and passes either directly or through storage to the vacuum unit. The residue is fed through the heat exchangers, where it is warmed by heat from the hot products of the unit. It is further heated to a high temperature in the atmospheric residue heater. It leaves the heater in several large pipes which carry the residue into the base of the main tower. Remember that inside the tower there are 25 trays and a packed section. The vacuum in the tower is maintained by the ejectors which draw off steam and uncondensed vapor from the top. The first stage ejectors are at the top. Their condensers, together with the second and third stage ejectors and condensers, are lower down. The vacuum gas oil is drawn from below the packed section near the top of the tower. It is collected in a reflux receiver, cooled, part returned to the tower as reflux, and the remainder sent to storage. At various levels down the tower, the composition of the descending liquid corresponds to that of a required product, so a side cut is taken off. All the side cuts are piped away from the tower and stripped in this tall stripper tower. Then the cuts are partly cooled in heat exchangers before being passed to a water-filled cooler tank. The stripped vacuum residue from the bottom of the stripper section of the tower again goes through heat exchangers, and if not pumped direct to the lubricating oil refinery, passes through its own cooler tank to storage. Remember that frequent sampling keeps a check on the quality of the products. So here once again are the products of the vacuum unit. In this refinery, there are two similar vacuum units side by side. Selected distillates are passed to the lubricating oil refinery, whilst the remainder constitutes the feedstock for the catalytic cracker.